Okay, guys. Today I'm going to continue our discussion about derivatives. Okay. So remember, if you have a function, the function. So we define the derivative. So derivative of f, function f, at x equal to a is defined by this formula, by this limit. And I'm using this notation, f prime of a means exactly the derivative of f at point x equal to a. So that is f prime of a, which is given by this limit of f of a plus h minus f of a divided by h goes to 0. So first thing to notice about this limit is that when h goes to 0, and assuming that f is continuous, then this f of a plus h minus f of a would be 0. Divided by h, again 0. So this is a 0 over 0 limit. So it's an indeterminate limit. Okay. So that means usually we have to determine the value of this limit by doing some computations. Kenny, you were not here. We discussed about the derivative of a function at this some point is given by this formula, by this limit. Okay. So, for example, I want you, and we do it together. So this is an example. Assume that f of x is equal to square root of, for example, 2x plus 1. Okay? So I want you to find, compute f prime at 0. So another thing, before doing this, let me tell you another thing, which is important. So the derivative basically indicates the rate of change of a function. Because you see this fraction, look at this fraction. In this fraction, the numerator is the change in the value of f when it goes from a to a plus h, and this is the change in x values. So this numerator is the change in y values. This is the change in x values. So this is the rate of change of the function f. As h goes to 0, it becomes the instantaneous rate of change. So we also call this expression instantaneous rate of change of function f at point A. So remember this.
Can you write it down?
Yes. So this is also known as instantaneous rate of change of f at x equal to a. So for this example, f of x equals root 2x plus 1, and I want you to compute f prime of 0, that is the instantaneous rate of change of f at x equal to 0. So by definition, f prime of 0 is equal to f of 0 plus h minus f of 0 divided by h. I mean, this is the limit h goes to 0. So this would be equal to the limit of f of h minus f of 0 over h goes to 0. Now, what is f of h? F of h is root 2h plus 1. What is f of 0? What is f of 0? 1 minus 1 over h, and h goes to 0. As we saw this before in many examples, if you have like a root something, you can multiply by its conjugate. So you can multiply this by root 2h plus 1 plus 1. So you have also to divide by this, because when you multiply something, you also have to divide it by the same thing. Now, once you multiply by its conjugate, so it's like a minus b times a plus b. So you have a squared minus b squared. So what you get on the top, I'm going to write it here. So the numerator would be what? Tell me. So the numerator would be 2h plus 1, because root 2h plus 1 square is just 2h plus 1. So you have limit of 2h plus 1 minus 1 divided by h times root 2h plus 1 plus 1. And h goes to 0. So here you have plus 1 minus 1. They're gone. So you have 2h divided by 2h is just 2. So h is gone. So on the top you have 2. And when h goes to 0, so you have 1 plus 1, you have 2. Okay. Now, next step, what we do is, so here I give you a point. So it's a particular, I specify a point. What if I want to find an expression for f prime at a general point, like x, okay? So this is called the derivative of f as a function. So what does that mean? That means if you want to compute the derivative as a function, that means for a general x, like f prime of x. So f prime of x, by definition, is the same definition. It's limit of f of x plus h minus f of x over h goes to 0. So this gives you a formula for any general x. So here x is 0, but you can compute a formula for general x. Let's do it for this function. So suppose again that this is an example. F of x is exactly this function, root 2x plus 1. Now we want to try a formula for f prime of x, in which x can be anything, okay? So f prime of x, by this definition, is the limit of f of x plus h. So f is that, so it's the limit of 2 times x plus h. So I'm using this formula. So f of x plus h is root 2 times x plus h plus 1. F of x is just root 2x plus 1 divided by h. H goes to 0. Here again, I want to multiply this by, so the whole thing by root. Oh, by the way, this is 2x plus 2h plus 1. So it's 2x plus 2h plus 1 plus root 2x plus 1 divided by the same thing, 2x plus 2h plus 1 plus 2x plus 1. So if you multiply, then the numerator would be this guy squared minus this guy squared. So it would be equal to the limit h goes to 0 of 2x plus 2h plus 1 minus 2x plus 1 divided by h times root 2x plus 2h plus 1 plus 2x plus 1. Okay. So what is the numerator now? 2x plus 2h plus 1 minus 2x plus 1. 2h. So it would be equal to limit of, on the top you have 2h. At the denominator you have h times this guy. So I just keep it. I don't touch it. So it's 2x plus 2h plus 1 plus time the same thing, 2x plus 1. And h goes to 0. Now I can cross out h with h. So the 2h cancel out each other, right? Now, if h goes to 0, what happens? If h goes to 0, then this root would be just root 2x plus 1, right? If h goes to 0. This guy is also 2x plus 1. So you have 2 times 2x plus 1, right? So you would get what? On the top you have 2. At the bottom you have 2 times root 2x plus 1. So this equal to 1 over root 2x plus 1. Because this, when h goes to 0, this is just root 2x plus 1. This is also square root of 2x plus 1, so you have 2 times square root of 2x plus 1. Okay, so the conclusion is that if f of x is this guy, square root of 2x plus 1, then in general, we can say that f prime of x, so if f is this, then f prime as a function is 1 over 2x plus 1. And this is a very important concept because first we have a function, we compute its derivative, and we obtain another function, a new function, which is usually different from the first function. So you get a function, you have a function, you compute its derivative, and we obtain a new function. So now I want you to compute the derivative of x squared, f of x. This is an exercise. Oh,
It's fine. I'm the letter.
sorry. I can write this again if you want.
Yeah, I'm right there.
So this is, I can write it. This was f prime of x is equal to the limit of root 2x plus 2h plus 1 minus root 2x plus 1. And here I multiply it by this guy. I just multiply it by its conjugate, which is 2x plus 2h plus 1 plus 2x plus 1. Okay, so the exercise I want you to do is to compute f prime of x for these functions. A, f of x equal to x. B, f of x equal to x squared. And C, f of x equal to x cubed. And remember what is the formula for f prime of x in general. So I'm writing it here on the top. F prime of x for any function is the limit of f of x plus h minus f of x divided by h. H goes to 0. So I want each of you to do, so I want all of you to do this 3, but I'm going to ask you to do it here on the board. Each of you have one, okay? So do it.
All of them, then you choose which one.
I will choose randomly.
X.
It's a probability. You flip a coin or something. Okay, so for f of x equal to x, f prime is 1. For f of x equal to x squared, f prime is 2x. For f equal to x cubed, f prime is 3x squared. So in general, if f of x is x to the power n for some integer, like 2, 3, 1, but it could be 4, 5, 10, any integer, then f prime is equal to, this is a general formula, n times x to the power n minus 1. Okay, so this is our first formula or first rule. So the derivative of polynomials. The derivative of polynomials. So this is what we learned. So we can prove that in general, if f of x equal to x to the power n, where n is an integer, and is an integer, then f prime of x is n times x to the power n minus 1. So, and the remark is that this is true, the above formula is true for negative integers. Is also true for negative integers. So be careful. N can be a negative integer. For example, let's check it. For example, if when n equal to -1, then we have f of x equal to x to the power -1, which is 1 over x, right? Now, let's compute the derivative of this. I want to check if the formula is correct or not for negative integer, right? So f of x equal to 1 over x. So let's check it. F of x equal to 1 over x. Then f prime of x is the limit, again, f of x plus h minus f of x over h goes to 0. And this would be equal to 1 over, and also the limit, h goes to 0, 1 over x plus h minus 1 over x over h goes to 0. Okay, I'm going to continue here. So let's compute 1 over x plus h minus 1 over x. So this is the limit. So the common denominator is x times x plus h. I want to subtract these two fractions. So the common denominator is x times x plus h. And then if you divide this by this, you get x. So you have x minus x plus h. And then divided by h here. H goes to 0. So here on the top, you have limit h goes to 0. You have minus h. And at the bottom, you have h times x plus h. Right? So now you can cross out h with this h. And when h goes to 0, so here h goes to 0, so you have x times x is x squared. So this is minus 1 over x squared, which is equal to minus 1 times x to the power minus 2. Right? So this formula is correct. So our prediction is correct. If f of x is 1 over x, which is x to the power minus 1, f prime would be minus 1 x to the power minus 1 minus 1, which is negative 2. Got it? I mean, so the point here is this formula is correct in general, even for negative numbers. So this is the first rule. The second rule is that if a function is constant, so if imagine that you have a constant function, what would be the derivative? This is another theorem. So it says that if f of x is equal to constant, f of x equal to c, I mean constant, like f of x equal to 1, constant, then f prime of x is what? If you use the limit, the formula, what you get? You remember this formula? On the top, because it's constant, f of x plus h is equal to f of x, right? So on the top, you get 0. But this is 0, not like h goes to 0. This is actual 0. So f prime is just 0. And the reason, as I said, so the proof, let me proof is very easy. So because f prime of x is equal to the limit of f of x plus h minus f of x over h goes to 0, and this is the limit of c minus c over h goes to 0. This is the limit 0 over h. Okay. So for a constant function, the derivative is 0. So that means, so for example, constant function means, for example, when n equal to 0 in this formula, if n is equal to 0, then you have f of x equal to 1, right? So f prime of x would be 0 times whatever. So it's 0. So this formula even true when n is 0, right? Because when n is 0, you have a constant function, and the derivative of a constant function is 0. So that verifies this formula for n equal to 0. Okay. So that means this formula is actually true for any integer, even for n equal to 0 and for negative integers. Okay. So far, so good. So now we have some other rules for derivatives, which are basically some. So here, so now the question is, so imagine you have two functions. So you can compute the derivative of each of them. So now what is the derivative of the sum of the two functions? The difference of the two functions, the product of the two functions, or the quotient of the two functions. Okay. So here is the derivative of sum, subtraction, multiplication, and division. So let me begin by the derivative of sum. Sum of two functions. So if you have, I'm writing like this. If you have f of x and you have g of x, so the question is, what is the derivative of f of x plus g of x? And the answer is, this is equal to f prime of x plus g prime of x. I mean, you can also write this as f plus g of x. These are the same, these two. That means the sum of two functions. Okay. This formula is also true for subtraction. So the derivative of either plus or minus. So here, simply, you can say that the derivative of the sum is sum of derivatives. Derivative of the sum is sum of derivatives, or subtraction also. So then you have product rule. Product means multiplication of two functions. So that is, what is the derivative of f of x times g of x? So this is more complicated. This is equal to derivative of the first one times the second function plus second function times the derivative of the first function. So f times g prime, f times g prime is f prime g plus f g prime. I mean, we can prove this principles, but I'm not going to prove them because it's not much helpful in this course. So the derivative of the product, here is the rule. F times G prime is F prime times G plus G prime times F. Okay, it's easy to remember. And the last thing is the quotient rule. So the last thing is the quotient rule. And that is the derivative of the quotient. So f of x divided by g of x prime is equal to f prime times g minus g prime times f divided by g squared. So let me give you an example. So as an example, so assume that f of x, for example, is equal to 2x plus 3 and g of x is equal to x cubed minus x. And we want to compute derivative of f times g. So there are two ways to compute this derivative. One way is just using this product rule. If we use product rule, so just product rule says that this is equal to f prime times g plus g prime times f. Now, what is f prime? What is f prime? What is the derivative of 2x? Oh, and I didn't tell you something, but maybe I just write it here, which is important. I mean, it's an example, a particular case for this, a special case for this, but it's good to, if I state it separately. So this is another rule. Let me write it by red. So this is basically a special case of this rule. And that is when you have a constant function, or when you have a constant times like c, and you multiply it by a function, if you want to compute the derivative, then this would be equal to just c times f prime x. So when you multiply a function by a number, like 2, 3, like here, if you want to take the derivative, you just take the derivative of x, basically. You just take the derivative of f. This is an important rule. So c times f derivative is c times the derivative of f. Okay? So here, a very important rule that we use it a lot. For example, here, look, 2x, if we want to take derivative, you just take the derivative of x, which is 1. So the derivative of 2x is 2 times 1, 2. And the derivative of 3 is constant, remember? 0. So 2 plus 0 is just 2. And you add the derivatives, right? How about g? What is g prime? What is the derivative of x cubed? 3x squared. The derivative of x? 1, so minus 1. You see, I'm using also the sum rule or subtraction.
Wait, why is it 3x squared?
Because in general, I told you the formula, x to the n. Actually, you computed the derivative. You did this example.
Oh. How did you get it?
First of all, he computed x cubed
In the,
in one of the examples.
so you compute x in x cubed x.
The derivative of x cubed is 3x squared.
In that one.
Huh?
How'd you get 3x cubed?
So the derivative of x is 1. So the derivative of x cubed is, sorry, x cubed is 3x squared. This is 1. So this is just, what is the problem? So in general, remember the derivative of x to the power n is n times x to the power n minus 1. This is the formula you can use for any polynomials, like powers. X squared, x cubed, x to the power minus 1, minus 2, whatever. Now, if you use the product rule, what you get? So the derivative would be equal to, what is f prime? Is 2. So it's 2 times g, 2 times x cubed minus x, plus g prime. G prime is 3x squared minus 1 times f. F is 2x plus 3. Can you simplify this for me? Write it in one line. What is it? So you have 2x cubed, then you have 3x squared times 2x, 6x cubed, which is how many x cubed you have? So it's 8x cubed. Then actually, yeah. Then you have 3x squared times 3 is 9x squared. What else you have? 9x squared, then you have minus 3, and you have minus 2x. Please check that this is correct or no.
I got negative 9x squared plus 2x.
Where did you get negative 5 from? Please check this.
I got 8x cubed plus 9x squared.
Yeah, so this would be, you have minus 2x, minus 2x, minus 4x you have here. Right. Okay. It seems that now it's correct. So this is one way. Another way, another approach, this is let me write it as a second approach, is to first multiply these functions and then compute the derivative. So this is another approach. So this is another approach. Let me write it like as a second solution. So what is f of x times g of x? So let's first compute f of x times g of x. What is it? Compute it. So 2x plus 3 times x cubed minus x. So it's 2x to the power 4. Then you have minus 2x squared. Then you have 3x cubed minus 3x. Right? If you multiply, just multiply f by g. So now you can take the derivative just after multiplication. So f of x times g of x, the derivative would be equal to the derivative of this guy. Now let's compute the derivative of this guy. What is the derivative of x to the power 4? Is 4x to the power 3. But here you also have 2, so you have to multiply it by 2.
It's 2 times 4.
Exactly. So it's 2 times 4 times x to the power 3 minus, you do the same thing. 2 times 2 times x plus 3 times 3 times x squared minus 3. So which would be equal to 8x cubed minus 4x plus 9x squared minus 3. Which is exactly the same result we have here.